this video, we will work on solving systems of equations by elimination using multiplication. First, let's review the steps to solve a system of equations with eliminations. First, line up the like terms vertically. Equal signs should be lined up as well. If the x or y terms are opposites, then add the equations together. If the terms are not opposites, multiply one or both equations by a number so that there are opposites, and then add the equations together. You should have as a result one equation and one variable. So you can solve for the variable. Substitute into one of the original equations to find the other variable, and finally write your answer as an ordered pair. Our example gives us the system negative 10x plus 2y equals 24 and negative x plus 6y equals 14. If I want to solve the system, you can choose to go about it a number of different ways. If I wanted to make the x terms cancel out, I notice that if I multiply the bottom equation by negative 10, it'll give me, so my original equation will stay as negative 10x plus 2y equals 24. And if I multiply everything in that second equation by negative 10, I'll have positive 10x minus 60y equals negative 140. Now if I add those two equations together, negative 10x plus 10x gives me 0x. 2y minus 60y is negative 58y. And 24 minus 140 gives me negative 116. Now that 0x cancels out and I don't have to write it. So my equation is really negative 58y equals negative 116. To solve for y, I would divide both sides by negative 58 to get y equals 2. Now I can plug that back into one of the original equations. So if I plug into the first equation, I have negative 10x plus 2 times 2 equals 24. If I solve that equation, I'll have negative 10x plus 4 equals 24. Subtract 4 from both sides to get negative 10x equals 20, and divide both sides by negative 10 to get x equals negative 2. So the solution to this system is negative 2, 2. Our next example gives us the system 4x plus 2y equals 6 and 10x minus 10y equals 0. If I want to make the y terms cancel out, I can multiply the first equation by 5. So if I multiply every term by 5, I'll get 20x plus 10y equals 30. My second equation will stay the same. So I'll have 10x minus 10y equals 0. Now if I add the two equations together, I'll get 30x, 10y minus 10y gives me plus 0y equals 30. And remember that 0y cancels out. So my equation becomes 30x equals 30. To solve for x, I divide both sides by 30 to get x is equal to 1. Now I can plug that into one of the original equations. If I plug into the first equation, I'll have 4 times the value of x, which is 1, plus 2y equals 6. If I solve, I'll have 4 plus 2y equals 6. Subtract 4 from both sides to get 2y equals 2, and divide both sides by 2 to get y is equal to 1. So the solution to this system is 1, 1. In this video, we will talk about special cases of solving systems of equations with elimination. First, if the system results in a true statement, then there is infinitely many solutions. So for example, you could have 5 equals 5 would indicate infinitely many solutions. If the system results in a false statement, then there is no solution. So if you use something like 4 equals 0, which isn't true, then it would be considered no solution. Now when I add straight down, I get negative 12x plus 12x, which is 0x, 6y minus 6y, which is 0y, and 50 minus 30, which is 20. Now we know that the 0x we really don't have to include, and the 0y we don't have to include, so it becomes 0 equals 20. Now since this is a false statement, meaning 0 doesn't equal 20, this is what we call no solution. In the second example, if I decide to multiply the second equation by 3, my first equation will stay the exact same. So I have 6x minus 3y equals 6. And the second equation becomes negative 6x plus 3y equals negative 6. Now when you add straight down, 6x minus 6x is 0x. Negative 3y plus 3y is 0y. And 6 minus 6 is 0. Now we know that the 0x and the 0y we don't have to write, so this becomes 0 equals 0. Now since this is a true statement, this is what we call infinitely many solutions.